Good morning, pre-calc. Hope you guys are doing well. So we're going to continue with matrices this week, but before we do, just want to give you a quick update on what to expect this week and next week. So this week we're going to go ahead and do our last little section on matrices, and then next week we'll do a major assessment, so a unit test. That'll be pretty short, basically, because we haven't done too much with this stuff. We weren't able to get through as much as I'd like, but just to give you a heads up. So let's jump into this. Today what we're looking at are determinants. So a determinant is something that any square matrix has. It's just going to be a real number. It could be a positive, a negative number, but it's going to be a real number. And the way we denote these guys, if we have a matrix A, we just can write it as DET and then A in parentheses, so determinant A, or more commonly like that. Kind of looks like absolute values almost. So that's the symbol to represent the determinant. So when we're dealing with a 2 by 2 matrix, because remember this determinant's only happening with a square matrix, so same number of rows and columns, we call it a second order determinant. So to find that determinant, we use this rule. Given that we have a matrix A that has elements A, B, C, and D, our determinant, remember, which looks like this, is equal to AD minus CB. Okay, so we would take this element times this element and subtract this element times this element. Okay, so let's go ahead and find the determinant for these 2 by 2 matrices below. So remember, all we'd have to do here is AD, so that's negative 4 times negative 10, that's 40, and then we're going to subtract 3 times 5 is 15. So it looks like the determinant for this matrix is 25. Now, here we have negative 6 times negative 2 is 12, and we're going to subtract negative 3 times 11 is negative 33, and that gives something like 45. Okay, so go ahead and pause and try out numbers 3 and 4 and try and find the determinant for those guys, and unpause when you're ready. All right, so with this guy, 5 times negative 9 is negative 45, and then we got minus 35, and it looks like we get something like negative 80. And then for number 4, should have had negative 16 minus 24, and that gives you negative 40. So those are the determinants for those guys. Right. So now let's move on to 3 by 3 matrix, which are called third order determinants. And these ones get a little bit more complicated. So we're going to have a few steps that we're going to follow here. Okay, first off, we're going to rewrite the first 2 columns to the right of the matrix. So I'm going to say a step and then we're going to do it. So here's our matrix and first 2 columns. So I'm going to rewrite them. I'm going to do 3, negative 5, and 1, and then negative 7, 4, and 5. Now you see how I just rewrote the first 2 columns to the right of the matrix. And then I'm going to find the sum of the products of each downward diagonal. So when I'm talking about downward diagonal, I'm talking about that right there. So we have 3 times 4 times negative 1. Okay, that's negative 12. We got negative 7 times negative 5 times 1. That's positive 35, right? And then we have 2 times negative 5 times 5. That's going to be negative 50, I believe, right? All right, so I'm going to add them all up together, and I get negative 27. Okay. And now let's move on to step 3. Okay, so here, this is step 2 that we just did. For step 3, we're going to find the sum of the products of each upward diagonal. So that's these guys right here. So the first one is 1 times 4 times 2, that's 8. 5 times negative 5 times 3, that's negative 75. And then negative 1 times negative 5 times 7 is positive, negative 35, right? Okay, and when I add all those guys together, I get something like negative 102. Okay, and then finally, subtract the upward diagonal sum from the downward diagonal sum. So let's keep track of everything. Upward diagonal sum, that was this guy. And downward diagonal sum was this guy. So we're going to take negative 27 and we're going to subtract negative 102 from it, and we get 82. So there's our determinant for that matrix. Okay, so let's go ahead and try one more of these 3x3s. If you want, remember our notes have these following guys like 7 and 8. We're just going to do number 6. So let's check this out. First off, we do 6, negative 1, negative 3, and then we do negative 3, 4, and 6. And let's do our downward diagonal. So 6 times 4 times negative 4, that's 24 times negative 4. I think that's negative 96. And then we do continue on. Remember, we're finding the sum of these guys. Negative 3 times negative 3 is 9, times 2 is 18. And last one there is negative 36. That gives us something. Ooh, sorry, you know what? That should have been a negative, so that should be positive 36. Sorry about that. And that gives us something like negative 42. Okay, so that was our downward diagonals. Now let's do our upward diagonals. Okay, so that's this guy. Okay, that's going to be negative 3 times 4 is negative 12, times 6 is negative 72. And we got this guy right here. That's going to be negative 12 times 6. That's another negative 72. And negative 4 times negative 1 times negative 3 will be negative 12. When I add them up, I get negative 156. And then to find my actual determinant, I just take the negative 42 and I subtract the negative 156 from it to get 114. If you want to try out some numbers 7 and 8, here I'll just write the answers real quick. This one you should get negative 38. This one negative 162. If you want to see the work for those, just go ahead and check out the notes. So now let's take a quick look at how we could actually use this determinant. In our next lesson, we're going to check out how we can actually use that determinant to solve systems. But here's just a little situation where this could potentially come to play. So say we had a triangle with vertices x1, y1, x2, y2, and x3, y3. So that's just 3 points on a coordinate plane, and that makes up a triangle, right? We can actually find the area of that triangle by using this little formula. The area is going to be 1/2 times the determinant of x, where x is represented by this right here, right? Where we put our first point, our second point, our third point, and then this column is just all ones. Okay, so if we want to find the area of triangle PQR, which has these vertices, okay, first off, we can figure out what our area is by doing 1/2 the determinant of this matrix. It's going to be negative 5, negative 2, and then 1 for all these guys. I can put them all there. We got 3, 9, and 7, negative 4. Right. So what we want to do is we want to figure out what the determinant of this matrix is and then just multiply it by 1/2. So we're going to have to do the same work we did in our previous problem. So I'm going to go ahead and I'm going to do negative 5, 3, and 7. I'm going to do negative 2, 9, and negative 4. Okay. And then we can go ahead and do our downward diagonals. So that's going to be this guy to start. Negative 5 times 9 times 1, negative 45. Negative 2 times 1 times 7 is negative 14. 1 times 3 times negative 4 is negative 12. And that's negative 71. Okay, and then we can do our upward diagonals. First one looks like this. That's going to be 63. Second one is positive 20. And the third one, 1 times 3 times negative 2, that'll be negative 6. And we get something like 77. And then remember, to finish off, we do negative 71 minus 77, which gives us negative 148. And when we go ahead and plug that in, we get 1/2 times negative 148, which is negative 74. Okay, so if you'd like to try out number 10, you can go for it. The solution is available in the notes. What I want us to do is flip over to homework 6 we're going to be checking out. Okay? And I want you to go ahead and try out, let's just do 1, 3, 5, and 6. Right? Hope you guys have a good day.